Hi, Algebra 2. Today we went through a lot of properties of logs, maybe not a lot, but several. And it's a lot of information, which is why I think I told you I was going to try and give you a little bit more simplified homework. But even in making that homework, I realized there's something I wish we had spent a little bit more time on. And this is that something, okay, this particular property. And I want to, and of course this property sort of goes with it. And that is that you have a base of the log and a base of an exponent, that they sort of cancel each other out is how you kind of can think of it. Technically that's not canceling, but basically whatever number is here is what the whole thing becomes. Not log of that number, just that number. Same thing here. This is the base of your exponent, this is the base of your log. Everything comes down to just whatever that number is. So for instance, if I have log base 3 of 3 squared, that's just going to simplify. The whole thing is just going to become 2. That's it. It just becomes 2. Now here's the part that I feel like we talked about that, but I feel like we didn't spend enough time on, and that is because of this property. That means anytime you have a logarithmic expression, you really need to look at this whole thing here, everything after the base, and see if whatever is there can be written as a power of that base. Let me give you an example. This could be log base 3 of 9. It could be written that way. And you have to recognize that, okay, 9 can be written as a power of 3. So that's the question you're asking yourself, is can this thing, which we actually call the argument, can the argument of the log be written as a power of that base? And then you would say, yes, it can. I can rewrite that as this, and my answer is 2. Okay? And same goes here with these problems. Like let's say you had, I don't know. Actually, it's the same does go there, and you can have problems like that. They're a little bit more complicated, so I don't want to look at them right now. So just be aware. Be aware that that could happen. So let's look at a few like that. Log base 5 of 25. Okay, so you're asking yourself when you read this, can 25 be rewritten as a power of 5? And of course it can. Log base 5 of 5 squared, and that's just 2. Notice that you can either use the property the way we wrote it, which is this, or you can use the other property, which sort of that one comes out of, which is that, or really comes out of that one. If you have log base a of a, that's always just going to be 1. In other words, no exponents. If you just have log base and the base matches your argument, if these two match and there's no exponents, it's just a 1. So let me show you how that looks here. Remember that, let's go ahead and rewrite it this way. Log base 5 of 5 squared. Remember that the power rule, the last rule we looked at, says this can be brought out front. So now this is equal to 2 times log base 5 of 5, and log base 5 of 5 is just 1. So 2 times 1 is 2. So you can kind of go a little bit more roundabout way to get there. You still get there. All right, so when I look at this expression here, log base 6 of 216, the first question I'm going to ask myself is whether or not 216 can be written as a power of 6. So I'm going to pick up my calculator and just start trying. 6 times 6. We already know that's 36, but it's a good start. Times 6. Oh, that's 216. So in other words, 216 is 6 to the 3rd. So this is log base 6 of 6 to the 3rd, which equals 3. Same thing here. Go ahead and think about whether or not 1024 can be written as a power of 4. Play with it if you need to. Turns out it's 4 to the 5th. And 5 is my answer. Okay, so those are still pretty straightforward, but I want to point out to you it can get a little bit more complicated than that. Not badly, but remember that we can also have negative exponents and we can also have fractional exponents. Here's what negative exponents do. They put it in the opposite level. Remember, it takes a negative exponent, takes something that's in the numerator and says, oh, it really should be in the denominator. Or vice versa, something that's in the denominator and says, it really should be in the numerator. So I can rewrite this as a power of 3, but because it's in the denominator, it's going to be with a negative exponent. In other words, this is log base 3 of 3. 9 is 3 squared, so this is 3 to the negative 2. 3 to the negative 2 is 1 over 9. So I have to recognize that I can do that and then say, okay, my answer is negative 2. All right, so looking here, log base 5, I have to decide whether this can be written as 5 to the something that's negative. So basically, is 125 a power of 5? It is. 5 times 5 times 5. 5 cubed is 125. So I can rewrite this whole thing as 5 to the negative 3. So I've got log base 5 of 5 to the negative 3, and so my answer is negative 3. I could even do it with a generic one with an x, something algebraic. I could say this is log base x of x to the negative 6. Take it out of fractional form. And then my answer is negative 6. Okay? What else can I do? I can also look at fractional exponents. Here, it's already set up so that this matches this. So all I have to do is say, well, that's 1/2. But let's think about how else that could have been written. What is 16 to the 1/2 power? 16 to the 1/2 means square root of 16, which is 4. So in other words, this is exactly the same as if it had said this. This is log base 16 of, and this is 16 to the 1/2 power. So again, I'm writing 4 as a power of 16, but it's a fractional power because 4 is a root of 16. And that is my answer. Okay, let me figure out what page I went on to from this. I jumped around here. Oh, there's one. Log base 8 of 8 to the 1/3, that's going to be 1/3. But what if it wasn't written like that? What is the 1/3 power of 8? The 1/3 power of 8 means the cube root of 8. That's what that means. The cube root of 8 is 2. So this is the same as if it said log base 8 of 2 and asked me, simplify that. So I have to think about whether or not 2 is the cube root or square root or maybe even 4th root of 8. And in this case, I know that 2 cubed makes 8. So that's why I can rewrite it like this and get 1/3 as my answer. So let's look at some of those. Log base 4 of 2. So the question is if I can write this as log base 4 of 4 to some power. 4 to what power would be 2? Well, it's the square root of 4, so it'd be 4 to the 1/2 power, so my answer is just 1/2. Same thing actually happens on this one. 5 is the square root of 25. So this is log base 25 of 25 to the 1/2. So my answer is 1/2. And finally, this is log base 343 of 7. So I have to figure out if 7 is a root of 343. So basically that means I think about what is 7 squared. That's 49. What about 7 cubed? Yep, it's 343. So 7 is the 1/3 power of 343. So log base 343 of 343 to the 1/3 power, it's just going to be 1/3. Okay, that's the main thing I wanted to show you, but while I got you, I can always show you one more thing. And that is this. We talked a little bit about this today at the very end. We looked at how if I have, let's say I have this, and I'm supposed to be writing it as a single log. Okay? It's a sum of two separate logs. To write it as a single log, I'm going to put it together as a product. But I have to take care of these first. I can't put them together with a number out front. So this has to pop up into the exponent. I have to use that property, that power property first, and say log of a to the fifth plus log of b to the third. By the way, what's my base here? 10. There's no base, so it's 10. That's a common log. Now I can rewrite it as a single log, still common log, of a to the fifth, b to the third. And that is my answer. Okay? What I wanted to point out to you is that if, let's say I have fractions out here. Let's say this is 1/2 log of a plus, oh, I don't know what I want to do. Let's go ahead and say 1/3 log of b. I would still be doing the same thing, popping it up in the exponent, and now we have fractional exponents. We don't want to leave it with fractional exponents. We want to remember that a fractional exponent means a specific root. So I would rewrite this as log of square root of a plus log of cube root of b. And then when I put it all together, forgive this scratch down here, log of, we don't usually have different roots in the same problem, so you're more likely to see one where it's both square root or both cube root. But it would be, that would work. I mean, that's what we have here. What I really wanted to point out to you about it is this. This is condensing, taking two things that are separate here, a sum or a difference. Words, they're tough. A sum or a difference, putting them together. We call that condensing, or sometimes we're just told, write it as a single log. Okay? So that's what we did here. What I wanted to point out to you is that when we do that, and you won't usually have both of them be under the radical, but when we do that, we do want to get numbers that are out front up in the exponent, and if it's a fractional exponent, you do need to go ahead and change it to a radical. When we're condensing, generally, this is just sort of I don't know that it's as much a rule as it is a standard. When we're condensing, we usually go into radicals. And if you were asked to expand, you would do the opposite. You would come out of the radical. For instance, let's say I was asked to expand log base 3 of square root of 5 times x. Notice that the x is not under the radical. Okay, these are times. Square root of 5 times x. To expand that, I'm going to break it apart into a sum. I wouldn't leave it that way. Usually if we're expanding, we want to break it down as much as possible, so we want to treat that like 5 to the 1/2 power. Square root is 1/2 power. And then bring this guy out front. So if you're expanding, get it out of radicals. If you are condensing or writing as a single log, if you're putting it together, put it into radicals. Okay? That's the other thing I just wanted to point out to you. Have fun on your homework. See you Monday.